when it comes to just Shor's algorithm and just Bitcoin, you actually do have something to worry about, but I think the idea that like NVIDIA's going to cry tears when quantum comes out because it's going to put them in business, that's, silly.
All right. Oh my gosh. Martin, thank you so much for coming. This is such a treat to have you. And it's a big day for you.
Thank you so much. Yeah, my wife's expecting.
Damn. Wow. This is like very exciting. She's like right on the cusp, going to be having a baby any day now, any moment now.
Yeah, baby right now.
Oh my gosh. Well, congratulations.
Thank you
you so much for taking the time to be here.
Thank you.
A little context of the show, just to like kind of set the container. So this is, we mostly focus on Bitcoin technology related topics. Quantum has been a relatively big topic as of late. We had Hunter Beast, who's the author of the first Bitcoin improvement proposal to try to introduce quantum resistant measures of various kinds into Bitcoin on the show recently. And a couple other kind of big quantum, mostly engineers trying to fix this problem.
Yeah.
And so, I remember you popped onto a Twitter space I was hosting maybe a couple months ago, where there was a debate. How much should Bitcoiners care about quantum in the first place? That was the set. That was the stage of the Twitter space. Yeah. And I remember you came on and you had like this like deep breadth of knowledge about quantum computers that I was not aware that you were really getting into this topic. I'm curious to start with how you got into quantum and sort of how this came up for you.
Yeah, I mean, anyone, any kid with a computer or anybody else, quantum sounds cool. And that's why it's become like this investment, bubble or theme or whatever. And you wonder like, oh, computers are so powerful. What's beyond the horizon? And people sort of typecast quantum as the next thing, which is conclusively the wrong thing to do. But, people do it anyway.
And is that, I mean, do you think it's just like quantum computing, like you said, it sounds sexy, there's like money to be raised around it? I mean, is that basically the deal right now?
I think the general approach or view that people have is that it's got to be the next level of computing or the next chapter of computing. And nothing could be further from the truth, but it doesn't matter, right? In a bubble, who cares?
Okay, so we'll dive into why nothing could be further from the truth.
Well, it's nuanced. Yeah.
We'll get into that in a minute, but I'm curious. So, like your take, generally speaking, right now, I mean, you would say that there is sort of like a quantum hype bubble moment happening right now.
Yeah, I don't think anyone, even the quantum people, would dispute it. There's no doubt. It was cold for a while too. So remember, every dog has its day, and AI was cold.
Right.
You have to be open-minded.
When did you think that this latest quantum bubble started to arise?
Oh, people have an exact date on it. I mean, the Google Willow chip. So Google,
was that it?
Yeah. So Google in 2019, I remember where I was because I was in prison. Put out a. And depending on how this Bitcoin
we're
goes,
going to talk about mathematicians in prison.
But no, all jokes aside, they put out this quantum supremacy paper, and had the dilution refrigerator on the cover of Nature. It was this great paper, and IBM immediately tried to counteract that it wasn't such a great paper, and it was quantum supremacy. And 2019 was great for scientists, but nobody cared outside of Google. And so I think the PR people at Google, who are very smart, sort of said, all right, next breakthrough, we're going to do something different. And so the next breakthrough happened, which is this whole idea of creating an error-corrected, quantum computer. And they made a breakthrough sort of roughly November, December. Really, it was December, I think, last year. And
it wasn't that long ago.
No, not at all. Yeah. And every quantum.
When did you get out of prison, out of curiosity?
2.5 years ago. Yeah.
2.5 years ago. Okay. So this was after, but you were learning. This was like 2019.
I paid attention forever. It was just that like every company in this space had been private. And, I think anybody watching like semiconductors or computers would always kind of keep an ear open for quantum. Like my old boss was, a real old timer on Wall Street. And he was like, oh, Martin, they've been talking about quantum since I started. And, every 5 or 10 years, somebody says it's coming. And then, it just kind of goes away. But again, AI did that. So you have to be open-minded.
Right. You never really know. But your take is sort of that this is probabilities farther away.
I think the nuance is there. I think that, if we're talking about Bitcoin, it's probably more closer than the theme of like, well, quantum is the next generation of computing, or it's the next important thing in computing. I don't think that's true. But I think that when it comes to just Shor's algorithm and just Bitcoin, you actually do have something to worry about. But I think the idea that like NVIDIA's going to cry tears when quantum comes out because it's going to put them in business. That's, silly.
Well, and this was, I remember, one of the key takeaways from the Twitter space that you brought to the table that no one else had even thought to mention was, quantum computing aside, there are other ways that ECDSA could potentially be broken.
Yeah, that's the craziest part of my thesis is that ECC, or elliptic curve cryptography, is only 40 years old. That's not long in the scheme of, either cryptography or just ideas in general, right?
Right.
Socialism is older. Bitcoin is not that old, right?
Right.
Itself. So
right.
You have this, I don't know, what are we now, 15, 16 years of Bitcoin and 40 years of ECC. These are still pretty young technologies.
Right. And most Bitcoiners would say, we're holding on to this asset thinking it's going to be 100 years. Right. Yeah, exactly. 1,000 years. Yeah, exactly.
And that's great. And I'm not, on this topic, I'm rooting for Bitcoin. It's important to have as much knowledge as you can. There's no such thing as too much information.
Okay, so we're probably going to end up circling back into why the timeline is what it is on quantum computing. But before we do, you said, I'm rooting for Bitcoin.
Yeah.
Right before the Twitter space, I will say, I did know that you were kind of prancing in the quantum computing field because you had mentioned, or I had heard through the grapevine somehow, that you were in the process of raising money to try to see if you could crack ECC. How did that idea come about?
Well, yeah, it's funny. You have a very, very good antenna because I only approached 2 people.
Oh, really?
Bitcoin. Well, they're 2 big people in the Bitcoin world, but they're still 2 people. And, And I had been doing this on the side for fun for a long time. And, I started to make some progress and start to really understand it. And, at this point, I said, I'm just a guy. I mean, I'm not a mathematician. I'm not a great computer scientist either. My wonderful woman is a tremendous computer scientist and also knows her way around quantum. I add my tiny bit of domain expertise here. And then we're sort of sitting there thinking, well, what if you did staff up and hire, she works over at OpenAI, and they sort of put together a brain trust and sort of said, we're going to do AI. And didn't have a particular we're going to make ChatGPT. That wasn't in the picture, that it was just, let's make great AI technologies. So if you sort of did the same thing with Bitcoin and I guess number theory or ECC or whatever, subtopic, I think you can make great things happen. But again, just like OpenAI, where they didn't have a profit motive, they didn't have any specific angle. This is a little more goal directed, but at the same time, it's fairly amorphous and we don't know how to do it. But, all the technologies that are around, breaking Bitcoin or cracking ECC, there are a lot of interesting things there. There's math, there's computers, there's, obviously quantum is a subset of the computer side. And there's non-computers, non-traditional computers, like things like thermodynamic computers, optical computers, DNA computers, these other interesting, modalities. So it's really this ultimate hacker question of what's the hardest system can you get into, and one of my buddies in prison was this Russian hacker who was this notorious guy. And he'd always brag about, he's like, JP Morgan was easy. Bank of America easier.
Were you in the prison for hackers? Was that?
No, it was eclectic. We had drug kingpins, cartel guys, people you don't want to ever meet. And then, this friendly Russian hacker.
And then the crypto criminals. Yeah.
It was funny because the guy that kind of replaced me at the prison I left, a week later, Virgil joined. The Ethereum guy joined.
Wow.
Right after. So, it is a rotating.
It kind of is. It is. There's this is a particular house. Yeah. Oh, man. Well, and you said that mathematicians, there's a long history of mathematicians doing deep work in prison. I don't know.
Funny. There, if you go way back, there's, some math professor reached out to me while I was in prison. We talked about, it's not super famous, but, a serious institution. And he was sort of, we were talking about all this and, he walked me through some interesting stuff, but he also mentioned that there are a whole history of mathematicians and even mathematicians that sort of have dreamt of or thought about going to prison for the solace.
Wow. Right. Go away, everyone.
Yeah, there's this great book called The Man Who Only Loved Numbers about Erdős. And Erdős was, legendary guy, but like he really only loved numbers.
Right.
So,
He didn't want to talk to anyone else.
Yeah, so like
It reminds me of A Beautiful Mind. Yeah.
Where else are you going to get that kind of solace?
I mean, I guess that makes sense. Did you spend any time thinking about Bitcoin hacking specifically?
Oh, yeah.
Oh, you did?
Yeah. So, I mean, it was kind of this dream, but like there were two great books that I read. One was the main ECC textbook, which is Van Stone's book. And I read that over and over and over again. And it's hard to get your head around this stuff. I mean, especially if you're not, a mathematician or anything. And, so I read that, and then I read Scott Aronson's book, Quantum Computing Since Democritus. And
both you read in prison.
Oh, yeah.
Oh, wow. Okay. The deep work on this, the ultimate Bitcoin hack.
Scott's book is like in between a textbook and a lay book, but he's obviously, one of the leading thought leaders on Bitcoin and on quantum.
Right.
And he talks about Bitcoin every now and then, which is cool.
Interesting.
So if you want to really, view it from the other side.
Oh, and quantum people you think do understand Bitcoin?
A little. I think like Scott does, because he gives so many talks in this. He's kind of like the Neil deGrasse Tyson, if I could say that, of quantum. He's
interesting.
A lot smarter. But, I think he's one of the smartest guys. But, so that's not an insult. Some scientists might think that's an insult. I'm sure Neil deGrasse Tyson is smart too. But he's really a great scholar, and he was over at MIT with my woman, my partner.
Amazing.
And they taught a class together, and he's just a tremendous, brilliant mind. And, he sort of talks about this idea that quantum is coming for Bitcoin someday. And he has a great blog. It's probably maybe one of the best blogs on the internet, because he doesn't do social media. He's just old fashioned, just like, I'm going to write you.
Love that for him.
Right?
Yeah.
And, it's called Shtetl Optimized. And it's, it's a math joke. And he's just a genius. And I think that, his book is sort of this weird introduction to his world, because quantum is like this weird thing where you have to know math, you have to know computer science, you have to know quantum physics. Already, you're talking about lifetimes of work, right? Like who's that smart?
Right.
I mean,
fair enough.
It's crazy. And that's the problem with I think, academia today in general, is that, these, they say John von Neumann was the last person to know everything. And at that point, maybe after 1940, knowledge just became too expansive. And Satoshi himself, right? There's this amazing kind of understanding of multiple things, including what is currency, what is economy, what is, all this stuff, monetary value, and then also having to know crypto, also having to know programming, also having to know, all these things. And somehow this thing actually survived. It's kind of amazing.
100%. Yeah. And there were several attempts, and this one popped through as the winner, right? So good for Satoshi. I'm curious of what came first, your interest in quantum or your interest in hacking Bitcoin?
Yeah. I mean, I think everyone, has sort of kept an eye on quantum. So even when I was, a teenager, there was this thought of quantum computing. Feynman was the guy promoting it, but I only kept loose tabs. When Bitcoin came out, obviously I paid attention, and around $100, funny story, I tried to short it. There's a guy who worked with me at my hedge fund, and he said, Martin, there's this fake money thing. We should short it.
We should short it.
It's worthless. It's gone up. It's a meme. Let's just find a way to short it. And we couldn't find a way to short it. Otherwise I would have just been like, yeah, sure. Let's short $1 million or something, and see what happens. And, that kind of got it on my radar. And then it finally sort of dawned on me 10x later that, this thing's here to stay and really cool. But it took a while for me to actually understand it, because I did a transaction. And once you do a transaction, it just hits you in the head like, this is great. I just sent somebody money,
Wow.
And this is awesome. And ever since then, I tried to think about, well, how does it doing this? And for at least a few years, I just said, I don't care. It's just doing it. And I trust.
Yeah, right.
Encryption's real. I trust all this stuff. And then slowly but surely, there are tons of Bitcoin people. A friend of mine went, full maxi, and he's just a normal guy, and he just got bitten by the bug, and he's just all in.
Good for him.
Yeah. And, really propitious kind of, thing to do. And then, we were sitting down in prison and talking about Bitcoin, and he's like, yeah, it's so great. I'm so glad.
He was in prison also.
No. He visited. Yeah.
Oh, he visited. Okay.
And, he's a music executive or something. And he basically came over and he said, I'm glad you're getting into it. And, what do you think? And this and that. And I was talking about ECC, and he said, I don't know what that is. He said, Bitcoin's, you got it wrong, Martin. Bitcoin's, protected by Shah. I said, no, not why? And he's like,
so he didn't totally do his homework.
Well, it's a funny thing is like,
most people don't know.
He's a great friend, and he'd been working on Bitcoin for, maybe 5-10 years at that point, and super early. And I'm like, listen, man, I'm not trying to insult you, but I'm like 100% sure, it's ECC. And he's like, I don't know. I'll let you know.
Right.
So even experts, are not 100%. Unless you're a programmer, unless you really get into the tech, you just take it for granted. It's secure.
100%. Yeah, 100%. Okay. So then when did we start to get into the, let's see if this is breakable conversation?
I mean, every system's breakable. I feel like there's, most hackers will agree that there's no such thing as a perfect system, right? And we've already seen Bitcoin be broken, right? We had an overflow bug that was exploited in 2010, required a full reset.
I'm actually not even familiar with that.
It's pretty esoteric, but it happened very shortly after.
What was the ramifications of that? What's it called? The overflow?
Yeah. So if you overflow, there's a whole host of family of overflow. I wouldn't call them exploits, but errors to really Stack Overflow. That comes from
makes sense.
Idea. And
was Satoshi still around then? Did he fix it?
He forked it. Yeah, he just undid it.
Wow, interesting.
So that happened. So there was MilkSad, which was wild exploit based on all this is human error, of course, not an ECC problem, but those things alone.
These are just coding bugs, basically. And there are lots of bugs. I mean, Bitcoin bugs get fixed all the time. Oh, totally. That's what core developers mostly do.
Right. And also the developers of the wallets, they mess up. And their side channel attacks, I'm not counting North Korea stealing your password. But, those types of things. But even this recent one, I've been talking to this guy who created this affine nonce attack. And this is still an implementation error on the wallet side. But he basically was able to discover if the nonces you use were erroneous, which is fairly subtle. That's somewhat subtle. You published a great paper on archive, and so there are people that are still cracking away at it, even on the side channel side. But in terms of the core side, obviously most people reasonably think that we're totally secure, and I think that's fine. The problem is, like I said, I think all systems eventually, it may not be this year, but eventually we're going to look back and laugh.
On a long enough time horizon, everything breaks.
Right. And we're going to look back and laugh and say, can you believe they had the whole economy was tied up in this thing, and they could just press a button, and if they only knew what button to press. But, there's a Windows 95 bug, actually. It's really funny, where if you, let's say somebody locked their Windows 95 system, and you, so it was the dominant OS at the time. There's some stupid thing you can do with Control-Alt-Delete that totally bypasses all the security. And today nobody cares because it's Windows 95. But it's a really funny thing. You can take a fresh copy of Windows 95 and say, all right, say this is Satoshi's computer or CZ's computer, and I really want in, and whoever it is, and but it's locked. How do I get in now? There's probably a lot of ways, but there was one really stupid, funny way where a certain combination of key presses just, that's it. And so, nobody knew or cared at the time, but, years later we find this out. So,
in retrospect, yeah.
Yeah. So I wonder if, staying one step ahead of the whack-a-mole is not really the greatest thing to do, but it's all we have, at the moment for Bitcoin. And, the question is, or is the velocity of those whack-a-moles coming faster and faster? And I think the answer is undoubtedly, because you have $2 trillion, right? I mean, once, at $2 billion, it's all right, well, I don't know, is this even worth the puzzle? And people do puzzles for fun. One of my associates, we haven't formalized this, haven't raised money, haven't made a firm yet, but one of the guys I'd probably hire is a very young guy and loves math, and he loves the Kryptos problem. So Kryptos is this CIA sculpture that they commissioned.
Okay.
And it's still unsolved.
Okay.
And it's a cipher. It's got it's a beautiful sculpture. And
okay.
It's literally at CIA headquarters. And
the sculpture is a puzzle.
Yes.
Oh,
yes.
And no one that we're aware of has solved it.
Yes, that's right. So somebody did a FOIA to the NSA. And the NSA produced.
Maybe it's just fake. Maybe it just doesn't have an answer. No.
Some people think that, right? And the CIA, the head of the CIA.
Maybe it's just a power trip by the CIA. It's a power move to
yeah. The head of the CIA was thought to have the answer, the only person, as well as the puzzle maker. He passed away and died with the secret. But now the puzzle maker is actually auctioning off the answer.
Oh, wow.
So
okay,
go figure.
Okay, so we'll get
given
somewhere.
enough hints, nobody's figured it out. But.
Do you have a point of view? So, like, one of the criticisms of Bitcoin that I hear, I talk about this a lot on the show, is this like ossification problem that just becomes increasingly more likely with decentralized governance over time, right? Like, how do you actually make changes effectively when you have a decentralized system, and given the fact that all systems are designed to break, do you see that as problematic?
Yeah, so I'd be the biggest maxi in the world if this problem was solved.
This is the I agree. I totally. This is my number one concern. Yeah. I'm with you.
I manage a software company. That's we do financial information software. Company's going great. Every time we add a developer, every time we grow our code base, the entropy is there.
Right.
It's something going to break. So
governance is the real challenge for Bitcoin.
Even with
more than not ECC. It's governance.
It's hard for us to keep our software from breaking, and there's no pot of money in there. There's no it's just financial information. So just getting we started with U.S. stocks, and the system's sort of okay. And then we got more users. And it broke, So now, we fixed that. Now we did international stocks. Broke again, and it's it takes years to fix it perfectly, even if you have brilliant software engineers. So how do you make something like this?
And centralized authority, telling you what to do and all of that. Yeah.
We still have downtime. We still have, bad actors. We still have all this stuff. And adding bonds, adding currencies, adding all this stuff. It's hard to make software. I mean, it really is. And AI is, a double-edged sword there. It can help and it can hurt. And I think that, this is the key issue is now I think people think that this money is so simple that you can make this code base simple and never have to update it. But I think that's wishful thinking. And I could be wrong. Maybe this will be the first version of software ever that could just, set and forget. Most software has to get upgraded. Most software has to be updated. And, you have all the memes and thoughts about these Fortran and COBOL developers that are still updating old JP Morgan mainframes, because the sedimentary layer, the lowest layer of JP Morgan is still COBOL and Fortran. You just chisel Java on top of that, and you chisel, C++ on top of that. And it's this slow process of, getting to the surface where a human being can see it. So I feel it is possible that you can make a set it and forget it Bitcoin, but obviously we're not there yet. If you look at the repo, it still has new code being added to it regularly. And, there's still, I wouldn't call them bugs or whatever, but there's still things to be done on the implementation side. So
yeah, there's totally bugs being fixed all of the time, minor whatever here and there, but that's absolutely a thing. So I'm curious about you have the sort of hobbyist interest in how this code could potentially break, how that might happen, but there's one thing to sort of have a hobbyist interest in. It's a whole other thing to raise money to try to figure out how to do it.
Yeah. So I'm pretty committed to doing that. I think the time has to be right and all of that. So I'm probably going to do it. I think the issue here is this is a very different kind of company. Nobody's ever done something like this.
Yeah, this is a project, basically.
Yeah, it's a big project. And I'd like to do it. I have other obligations. Principally my startup is my main obligation. And I have an obligation to my employees, to my investors, to my...
This is a side hustle, basically, for you.
It's so tempting, though, to do it because it's great. Creating a software company is great. I love doing it. I love what I do. But to go down in the annals of the glory of Shackleton or somebody that made this great voyage, this is up there. I think it's a huge monument.
Let's double click on this. Okay, so your core motivation for trying to break ECC and therefore, potentially do something like steal Satoshi's coins. Well, we won't say steal, but maybe we can get into that language later. Yeah. Hack Satoshi's coins. Your primary motivation would be the glory.
Yeah, absolutely. Yeah. This is
You think that this would be glorified, not villainized?
I think it'll be both. Now, remember, I have a problem with this, right? Okay. I always think glory, and then I end up villainized. But
that's going to be my next question. I was are you a person who cares about optics?
Yeah, that's something I notoriously get wrong every time. But I think that the mathematical side, what a paper, and people, there's been other...
it would be an incredible mathematical feat. That is for sure.
Yeah.
For sure.
There have been recent, I'll send you the latest one, but there was some crypto system that was broken in polynomial time, and it was massive, win. And now it's a system nobody used, but it was still one of these things that was like, wow, you know, and, you know, so it does happen. I mean, RSA is not going to get broken anytime soon, but like just recently, like the Dijkstra algorithm was improved upon by this Chinese group. And, you know, there have been other like really interesting advances. So Dijkstra's lasted 40 years without an improvement, and it just got not like massive improvement, but somebody made a faster algorithm. So, like, there are people that care about this stuff. And, you know, and
this is like a subtle point also on like, it might not be quantum. It could just be like advances in mathematics. Like, this isn't an effort that you're putting forth by any means. It's not necessarily quantum related. Yeah. It's just like the goal of breaking ECC ostensibly for the purpose of getting Satoshi's coins.
Yeah. I mean, I think that the getting the coins thing is certainly, I think, the direct outcome of it. You know, and you have to think about how to handle it.
That's the financial incentive. Yeah. The glory is the true intangible. Yeah.
The paper. Yeah. This is one of the most important papers ever, and if you could write it. And I think there are two. So we have basically it's like, you know, it's 4 or 5 people. I mean, it's a loose, unconnected group so far, but like, I plan to grow it and have real money behind it, and maybe get some mathematicians to take a sabbatical or like do something like that. For the right. I mean, I think a lot of mathematicians, they don't like to teach. They don't like to grade papers. They don't like to, they'd rather like Wiles, spent 10 years in his attic, but he did teach at the same time, but he spent 10 years in his attic working on Fermat's theorem, used elliptic curves to figure it out, by the way. 400-year-old problem.
All right.
So if he could do it, 400 years, now again, maybe 2,410, and somebody says, yeah, I got it.
Who knows? Yeah, I mean, who knows? Anything's possible.
But I think, we have 2 main attack points. One I would just generally say is computational, and the other is mathematical. So,
and you think computational being like all the different types of computers that come out versus just like advances in math.
Exactly.
That you think AI will actually potentially be the catalyst for those advances in AI. Advances in mathematics.
Yeah, so totally. So, my partner Chelsea, she has a front row view of this at OpenAI, but I think that, there are more than just even OpenAI. There's efforts by Vlad Tenev, the Robinhood founder, has his own math AI company. And, he's a mathematician. He, he's obviously living on top of the world with Robinhood's success. But the fact that he's got a $100 billion company, my startup's not worth that. And, the fact that he's found it fitting to have this distraction of starting a math AI company, it tells you the math is a special thing. To people who are mathematicians, they look crazy to anybody else, scribbling on a notebook, endlessly these meaningless symbols. It's like, who would do that? And it's like, once you get it though, you really do fall in love with it. And so I think that AI is one of these things where, again, the explosion of knowledge has created, mathematics was a fairly finite field, 200 years ago. And then as like these different branches branched out, topologists I talk to don't know anything about other fields of math, anything. Even within topology, they can't know all of it. So like there's just such a difficulty making these like connections of all of it. Now, what can know all of it? Maybe AI, and so there's maybe, I don't know, depending on how you look at it, somewhere between 20 and 100, sort of subtopics in math. And like you could spend your whole life studying just one, and you still would be like a bum, like there's still competition to be the best, and huge competition, right? So, to be the greatest topologist, like you got a long line of people who want to be that person.
So gun to your head, what do you think will break ECC first? Quantum computing or advances in mathematics prompted by AI?
Probably quantum.
Really? Yeah. Okay, so you think the AI thing is actually even farther away? Because you don't think quantum's that close. Didn't you short a bunch of quantum stuff?
Yeah, I've been short the quantum space, and that's my the whole point that I make is that quantum can't do quantum can't do anything useful. It will never do anything useful. And useful.
What why?
Yeah,
let's break that down.
Yeah, this is a good question, and almost nobody understands this. So computers at large, they have to run algorithms. And if you think just outside of what is the computer, whether it's an Intel, an AMD, an NVIDIA, it doesn't matter, an abacus. The algorithm is independent. The algorithm speed is independent of the kind of substrate or the form of computer. So there are algorithms that are fast. Like for example, sorting list, very fast. Even if you have 1 billion things, you can sort them fast. There's tons of algorithms to decide how to sort it. There's like 5, then they all do it differently. And, it's no matter how big your list is, it's fairly quick. So when you type a name into Facebook, it's doing a kind of a search sort type thing where it's like, well, where exactly, how do I find this person? So if you type my name on Facebook, like within a second, my photo comes up. Oh, that's him. So it's very easy to find, even in a list of a billion, the answer very quickly. Then there's algorithms that are not so easy. And those are so-called exponential time algorithms. So that the list algorithms are polynomial time. The exponential time, which sounds scary, and it is. Polynomial doesn't exactly sound welcoming, but it is the friendly version. And exponential time algorithms are the frightening, beasts. And, for factoring, every number you add to the factoring size of the factor, 200 digit, 300 digit, just going from 251 to 252 is exponentially harder. So each time is just exponentially harder. So by the time you get to 300, it's not even close.
Which is actually interesting, because I think one of the sort of bull cases for quantum that you hear from, founders and those invested in quantum is that there's going to be some sort of exponential leap in like error correction, for instance, and you're going to get a big jump up, and quantum will all of a sudden become possible, even though there's not that much going on with it right now.
And I know you're visiting companies and all that, and it's really cool.
Well, do you buy that?
Well, so let's get back to the analogy. So you have these two kinds of algorithms. Now we have to worry about, well, okay, if I run a sorting algorithm, I could sort a deck of cards, and there's actually an algorithm to do that. And the most famous algorithms book, CLRS, it starts with a card sorter, a card sorting algorithm.
Makes
so
sense.
you could do that. You can have an approach to the card sorting that's really slow, or you could do it in this way that's like actually the minimum amount of steps to resort the deck. So now we talk about computers, right? Computers, the fundamental unit of computers to me is cycles per second. So how many operations can you do per second, or cycles is sort of a surrogate for operations. So we talk about hertz. And when I was a kid, I had a 100 megahertz computer. I thought it was fast, but it was an abstract concept. But it's a real concept. It's 100 million cycles a second is 100 megahertz. Now we have computers that are around 3 gigahertz. And there's seemingly this like ceiling around 5 gigahertz that you don't want to go faster than.
You don't want to, or you just can't?
You just can't. Yeah.
Okay. Yeah.
So the better approach is just stack the other way, which is make more cores.
Right. Parallelism, essentially, which is what quantum ostensibly will do.
Well, that's kind of the nuance again. So Intel has 16 core, 32 core. The NVIDIA's 16,000 cores. Which is why it's so much faster. And you don't lose much on the clock speed. I think those clock speeds are a little lower than the Intel, but like the fact that you have so many, this is why NVIDIA is so valuable. Now, the problem is that with quantum, the clock speeds are not measured in gigahertz. They're not even measured in megahertz. They're measured in either hertz or kilohertz. So they're truly slow. So when people say quantum is fast, I have to, interrupt, because it's like, it actually isn't fast. It's that it can turn one of these algorithms from exponential time to polynomial time. And no matter how slow your computer is, it can be 100 hertz. It still will beat the NVIDIA because you're in polynomial time.
Right.
So when you can transport from exponential time to polynomial time, the problem becomes easy.
So, gun to your head again, what timing would you give for this? I mean, if you think quantum is the most likely threat to ECC, when should we start to be worried about this?
Yeah, I keep thinking about it. I think about it all day and all night. And, because I have the bet against quantum. But, just to wrap that up real quick is the bet against quantum is that we have a grand total of one impressive algorithm for quantum. There is no reason to use a quantum computer other than to run that one algorithm.
Which is
Shor's
Okay,
yeah.
right.
So Shor's is
that's basically all quantum will give us is Shor's algorithm.
I think so for now. Yeah.
Okay.
I mean, someday that'll change.
Eventually it'll be Grover's, and eventually we'll but
very embarrassing Grover's. But no, it could be Grover's. It could be some other ones.
But Shor's, which is the algorithm that could theoretically break ECC, is the low hanging fruit of quantum.
Shor's is the reason anyone wants to make a quantum computer.
Right. It's the only valuable.
Yeah.
Right.
Without Shor's, nobody would care.
Right.
Because Shor's says, I can take that 300.
Shor's protects good stuff.
Yeah.
Valuable stuff.
Yeah, no, you can make other protections too. But, Shor's says, I can take your 300 digit, biprime, semi-prime, chop it in two, and I know the primes right away. And that's, to a mathematician or a computer scientist, that's amazing. It's like saying it's like saying you can go to the moon or Mars or something. It's like,
right.
I don't believe you. And there's no way, and then it's like, this is a magic trick. You can.
So I mean, it's interesting because again, you're theoretically raising money for this, trying to like move forward with this project. But is this like something that you'd be working on for 30 years, or like what's the timeline?
Yeah.
Okay, so you're willing to work on this for 30 years.
Process. Yeah.
This is not something you think is going to happen in 5 years, even with your best efforts.
So again, it's hard to say. So let's think about it. I think quantum's your best bet because again, it's gotten this huge investment from this Willow PR. So the reason the Willow PR was so good is this time around, Google said, no, we're going to make this exciting. And they said that the PR person, I don't know who it is, but I want to shake their hand because they said
they crushed it.
They said, we are unveiling Willow. The last one was called Sycamore. So they're kind of doing this tree thing. We're unveiling Willow, and it's possible with this chip that we opened up a world, hidden universes or something like that. And people's just imaginations went wild. And they said, it was really like a bullshit kind of
right. It's a very fluffy sentence. Right. but like, right.
Out, yeah.
But this became like the investment, like an investable future, basically.
There's billions of dollars floating around with quantum and all the public.
And VCs kind of like ambiguous. I don't know this, but this is what I hear. They kind of like these sort of like ambiguous, anything could happen vibes. So do you agree with that?
Yes and no, of course, but, of course they want the future technology, but VCs are smart,
Yeah, fair.
They know that, so you haven't seen like the big names in VC, the Sequoias and so forth that invest in quantum, and
they have not.
No.
Okay, so there's not a ton of significant venture investment in quantum.
But
as far as
you still have someone like BlackRock investing in it.
Really?
Right? So they're the big.
That makes sense, right? I did read that. Yeah.
And
absolutely.
So I feel like there's interest, and private or public, you'll get the money. And I think the question is, because Google's doing it too.
Yeah. I wonder though, like you said, I remember on the phone we were chatting briefly, and I think you mentioned like JP Morgan and a couple other companies that were owned patents or were investing in
whole quantum department. Yeah.
That's amazing to me. Do you think that means that they're concerned about quantum, or do you think that means that they just think the patents will be valuable over time?
I think it just means that they want to be ready.
They want to be ready.
Because the first thing you might want to hack with a quantum computer outside of Bitcoin is, somebody's account.
Well, and the government apparently also wants to be ready. I mean, absolutely. They're, trying to, I think there was the mandate by Biden to sunset ECDSA by 2035, if I'm not mistaken.
Oh, yeah.
Why do you think they're implementing these if this is really not an issue?
I mean, I feel like, if you have, it is an issue.
It is an issue. It's just a matter of time.
Of when, yeah.
It's a question of when.
And the big thing is, again, if you gave me a quantum computer today and I could take it to Microsoft or OpenAI or XAI or whatever, they would all say, I don't need this.
But 2035, you would say, is like an abundantly aggressive timeline for
I think
this.
it's aggressive. Yeah, that's
unlikely in your opinion.
Now, I think it's
a non-zero pop.
It's non-zero.
Yeah,
for sure. I think that everyone has their own opinion, and I think instead of giving an opinion, maybe giving the facts, and letting people think about it is better. So, there's qubits and logical qubits. There's physical qubits and logical qubits. And a physical qubit we have. And we have these 150 physical qubit computer from IBM. And I'm not promoting IBM, but you can actually go on quantum.ibm.com. And instead of guessing and thinking and imagining, you literally go to this URL and they give you 10 minutes a month of quantum time on their real freaking quantum computer.
Oh, wow.
Yeah. And it's nobody wants to do this. So you can actually, if you look hard enough, you can see how many people are have used it or sent jobs in, things like that. And it's significant percentage is me. and I know
why do you think that is? If quantum's so cool and sexy?
I mean, you gotta get off your ass and program, and
it cannot be a simple thing to use.
It's not.
It's
also not, the hardest thing in the world. I mean, I think, you can do it. It's just a question. And again, learn by experience, right? I mean, you give it a shot.
You think people would be interested in using this thing?
I think if the more this gets out, the more people talk, I think they will. And, I posted some programs on my GitHub for anybody who wants to, try them. They work on the IBM machine and you'll learn very quickly the issues that are here, with the machine. So for example, we have 150 qubits. Great. Well, what does that mean? What does that help? How does that help us? Right. Well, the best way to think about it, I think, is fidelity. So fidelity is, if you have an AND gate, the two ones, what's the probability that the gate, which should always 100% be a one, true and true is true. True and false is false. So if you have true and true, what are the odds that you're going to see a true on the other side? Well, it should be 100%. Unfortunately, physics and reality, that's not 100%, even for NVIDIA.
You sent me that paper, by the way, about like what was it? It was like what can like factor this number like more easily, a quantum computer, a dog, or something else, right? And it basically proved that like anytime a quantum computer has been right, it's essentially been like a random luck. I mean, is that
it's a mix of random luck or contrived,
right?
It's just, like really set up to succeed, like. Set up all the
pins
to knock this down.
Yeah.
And, so I think that the fidelity, it sort of gives you the math you need. And so you can basically watch the fidelity and you'll know everything that's happening with quantum, because right now the best fidelity is like 99.99. And that sounds great. But when you do the arithmetic version, the decimal version is 0.49s. Do that to whatever power. And you do it to the second power, the fifth power, you still have like 99-ish% accuracy. But if you do it to the 500,000th power, you lose all hope of being right. So the gates are all they all have to work in this program. The Shor's program is probably going to be millions of gates. So you need the fidelity that's so high for the program to run successfully that at the moment, the fidelity is too low. Now, how do you get high fidelity? Well, you make a better qubit. People are working on that. They want to make the best qubit possible, whether it's shielded from noise or, special technique of, freezing the atom with a microwave versus a laser versus this versus that. Everyone's guessing what's the best way. There's a group who seems to be doing really well doing the fluxonium qubit. I don't even know what that is, but they report that they could have the best one. And now all these little adjustments aren't going to get you to 10 nines or 15 nines or 100 nines. And the NVIDIA machines we have are like 18 nines. Which is like, it's a real, my girlfriend was, helping set up this, sort of actually technically not married, by the way, but, she was, part of the team with the GPU team for OpenAI. And she said they were calculating how often like cosmic rays would come in and like accidentally switch, one, bit. That's called a bit flip.
Yeah.
It's a real thing. And believe it or not, and, it could, enough of those things can screw it up. So it screws it up with quantum all the time. So, isolating, lead shielding, there are all kinds of things you could do. But eventually to get all those nines, you need error correction.
Right.
And error correction is why when you scratch a CD, you can still listen to the CD.
You think error correction is where we need the most advancement, basically, when it comes to quantum?
Yeah. So it's error correction, which is there's a huge, academic literature on error correcting codes and so forth. That's why you have checksums, you have all kinds of things that work. But the problem is it's abstract, and then you actually have to do it in real life. And so you have these abstractions that are great, but now engineer, now get your hands dirty. And I think that's the hardest
part. And the
part.
hardware itself is so intangible and difficult to control, basically.
Yeah. I mean, you were talking about literal atoms, right?
Yeah. Right.
So in the case of at least...
You're not talking about wires and metal. Yeah.
Yeah, exactly. So you have to find a way and eventually when you get to enough of these things. So to make an error corrected qubit or a logical qubit, you need a lot of other qubits that you sort of form. It's not really consensus, but you allow them to hold up one logical qubit, and the ratio. Nobody knows if it's 1,000 to 1 or 5 to 1 or what, but it's something to 1. And so let's say it's 1,000 to 1, which it would be bearish, but 100 to 1 would be better, of course. And those all sort of if an error happens, you can sort of still withstand it and say, okay, 99 of them are reporting true. It's true.
All right. It's like a pregnancy test.
Yeah. Yeah.
All right, guys, I want to take a quick break to thank you for watching and remind you to click the follow button on my profile if you want more Bitcoin technical deep dives like this. I also want to give a shout out to my partners for making the show possible. My leading partner, Best in Slot, just released the programmability module for BRC20, making the execution of smart contracts possible for the protocol. I know that's been long awaited by the BRC20 community. Alongside this release, Best in Slot put out what is arguably the most sophisticated DEX for trading Bitcoin native assets called Coin Cooker, which I also highly recommend checking out if you want to dive into the BRC20 trading game and get started executing smart contracts on Bitcoin. I'd also like to thank Satreya, building one of the leading implementations of a BitVN style bridge for Bitcoin. Satreya is building what I think could become the canonical Bitcoin rollup, enabling programmability, scaling. Really anything is possible with a trust minimized bridge, which is the unique value prop of these BitVM style rollups on Bitcoin. Lastly, I'm thrilled to announce my newest partner, Spark, which is the leading state chains protocol on Bitcoin. State chains builds upon what was made possible by the Lightning Network for payments, but without the liquidity constraints and the UX challenges that often make self-custodial Lightning impractical. Spark is also led by one of the leading payments infrastructure teams on the planet, including founders from PayPal, Facebook. They're incredibly well positioned to turn Bitcoin into a true institutional standard for payment systems around the world, and I couldn't be more excited to support what they're up to. All right, on that note, let's get back to the show.
So error correction will get you that great 99999, but now the riddle becomes, okay, so we have 150 physical from IBM. So how do I get, like, I guess you need like 3n squared or 3n cubed for Shores. So depending on the size, so 256 is Bitcoin. So 256 cubed times 3, maybe it's a million, right? Now, how do I get a million logical? Means 100 million or even a billion physical.
Right. So and we're at, where are we now? We're at 155.
So
okay.
So now,
okay. Yeah. And so you're like, like you would say like what, 30, 35 years away? Like it's hard to even put a number on it.
Because like, the if your main thing is Shores, which, to me it is, but to the quantum people, it's like, if we're just doing this for Shores, we're wasting our time. Right.
That's how they feel.
Yeah. What's the point?
Right. They want like the whole world to be overtaken by quantum computers eventually. That's their ultimate goal.
Do like quantum simulations or something like that could be cool. And but the first step, I think, is Shores. Some people disagree with that. Some people think Shores is actually not the first step. But again, I would say that the reason we're making these things in the first place is for Shores. And if you think about how limited Shores is as an algorithm, like people want to use quantum to like simulate drugs or something like that. And it's like, it's actually way more complicated, like computationally, I think, than Shores, which is like, I'm trying to find this number, man. It's not that hard, representing the molecule and all of its states and things like that. Quantum doesn't have RAM. Quantum doesn't have really networking or throughput. So like, it's not simple to run a quantum circuit. And if you try the IBM computer, you'll sort of see, you'll get an intuition for like, oh, that's how it works. And, just like me discovering Bitcoin and like poo-pooing it until I actually tried it, it's the same thing with quantum. You actually have to try it and run a hello world, equivalent of hello world in Python or anything else. Run that hello world in quantum, and you'll gain a strong intuition immediately for how it works. And I think so. Making the qubits, making the logical, and then like expanding it is really like one of these like engineering questions. So one of the ways I think about it that I think is reasonable, but it's not totally reasonable, but it's at least something, is how fast are we getting more nines? And so we went from 99.9 to 99.99 in like 10 years, maybe 5 to 10 years.
Okay.
So it doesn't mean that it's going to take 5 or 10 years for every 9.
Right.
Some years or decades where we get 4 nines or 5 nines or 10 nines.
Right.
And all it takes is 1, right? So, if we do get that, then we're excited. But now the question is, now you need to scale. And so like ion trap and atom trap, I'm very bearish that you could actually entangle all of those qubits together. Like 100 million atoms is not a lot of atoms in a way. But in another way, if you have to control all of them, it is a lot.
So let's like kind of talk a little bit about like the game theory. So if you are, right, like let's just say for the sake of argument, exactly. Eventually, this will be possible. Who's going to have this technology first? You said you're raising money to try to do this, but then you're going to be competing with all these like behemoth quantum computing companies.
Behemoth is an interesting word because these companies were like forgotten and dead,
but they have somehow raised like
now they have billions. Like truth be told, like how much money these guys have actually put into their actual hardware is a pretty small amount, and relatively speaking, and
like most of it is just a jobs program for physicists.
I mean, it's now that's changing, right? I mean, they're going to put more money in, and some of them are probably going to spend as much as $100 a year on this stuff. Supposedly, Microsoft quantum department is up to like $300 a year. But
so like, how are you planning to contribute to this? How do you compete with this?
Well, so on my side, I'm just a customer, right? So like,
how does that look in practice? Like, what does that mean?
So it means, either cozying up to the companies or just being first in line one way or
like cutting some kind of deal with them to let you in on this.
Yeah, that would be
for the purpose specifically of getting Satoshi's coins.
And now you got liability questions. So if you're Microsoft and you say, well, it's just on our cloud, right? Day one, it's on our cloud. I'm an Azure customer. I say, okay, thank you, Microsoft Azure. Click start. I've got a quantum computer. It works. And you take, you decide that you want Satoshi's tokens. You take them. Well, isn't Microsoft more culpable almost than you are? They give you the tool. They give you the lockpick to, pick the lock. And, that's sort of a big open question. So, I mean, ultimately, I would imagine China, North Korea, there are going to be some unauthorized access potentially to quantum computers. There's going to be, prohibitions perhaps. I could see the quantum companies saying, we're not going to let anybody run Shores, unless it's in like a controlled environment.
I mean, sure.
That's
sure.
what I do.
I was going to say, how much do you think the state will play a role in this? Any of them?
If I'm IBM, and you want to use my quantum computer, well, we know right now you can't do anything with it. But like as it gets more serious, you might want to vet the customers and say, hey, what do you want to do with this anyway? And it's like, oh, I just want to divide this really big number. Well, why? What's your goal? And I think they may say, well, this number's safe to divide. We know that's not a private key, but that number is, give us some intel, like why that number, and I think it's very reasonable to do that. And now in terms of the government, I mean, it would be very trivial to pass a law that says, all Shores has to be, the Department of Shores, algorithm, the Department of Integer dividing, this math is illegal.
Well, it's interesting that IBM, I mean, again, and I think most Bitcoiners would agree that it's like sort of ridiculous. Like once this technology is available, we should be protecting ourselves against it. We should be like trusting IBM to vet their customers.
Right.
But
that's
it does,
a weak point.
right. But it does sort of beg this question. Like, do you see an ethical issue with attempting to even try to break this
major question.
ECC?
I mean,
what are your thoughts on that?
The math part is awesome, right? Like it's very cool technology, engineering, math, brilliant like question of like human achievement. Now, the money part. Personally, I wouldn't want to hold those tokens, right? I think that
you wouldn't want to hold Satoshi's coins or any like coins that came from, private keys that you
somebody else's
cracked.
property. It's their property, right? Like it's illegal. I mean, it's thievery, it's just very intellectual thievery.
Very intellectual.
Thievery, so you don't want to
It's very, very, very mathematically difficult to achieve thievery.
Yep. And so
so then why are you doing this?
Well, I think, the math problem is cool. The other
so you might try to do the math without actually taking the tokens.
And believe it or not, many people in AI did this, where they were more interested. Look at Jan LeCun. I mean, he works at Meta, but he worked at Bell Labs, and we should talk about labs at some point. But Jan's interest in AI is AI. It's not making, the pictures on your Instagram more, whatever.
Right.
It's just AI for AI's sake. So I think that, that's the main motivation. Now, there is a question about Satoshi's tokens, right? And I think this is very cool. And the game theory is very interesting. What did Satoshi want? Is ultimately what we're all like trying to guess. And one of the problems here, as we talked about briefly, is, well, independent of what you would do or what I would do, some point these tokens are like going to be fair game for anybody. And it may not be our generation, maybe our kids or our grandkids. But at some point, somebody who can literally whip out a quantum calculator, and say,
if it's possible to get them, eventually somebody will.
Yep. And so what do you do about it? And philosophically, I think you probably, if you're a maxi, you're saying, no, no way can we, alter Bitcoin just to exclude or just to make a special thing about these tokens. Because as you know, there's no way to quantum secure them. The only thing we could do with quantum secure Bitcoin is opt in. So any tokens that have been the public keys revealed, there's an out transaction. Those tokens, public keys have been revealed. Now, some of the Satoshi tokens, if not many of them, I think don't have an out transaction. So those tokens may be arguably safer because you could probably still get there, but it's a question of like the ones where there's an out signed transaction with ECDSA signature, you functionally have the public key. Now, working back to the private key is what, quantum computer could do quickly.
Right.
But you still have this like second step of, okay, what about the ones that don't have outs? You still have a hash of the private key of the public key.
Right.
So
Satoshi's coins, though, are pretty much all the output types all basically just have the public keys available on chain, pretty much. And then I think there's like most of the other output types are hash private key or hash public keys. So there, you would need.
I mean, it's just like I guess it's a question of like, a small hurdle versus a big hurdle, and
right.
But both are like quantum.
But Satoshi's coins will be the first to go. Those are the low hanging fruit.
I don't know necessarily, because I think like the lowest hanging fruit to me would be like a Binance.
Like the big honeypots but hopefully those guys will like get their acts together.
They'll opt in. Yeah. They'll opt in.
Satoshi probably won't.
Probably won't. Right.
Probably won't. Yeah.
That seems to be the consensus.
Probably won't move his coins before quantum computers come. That seems unlikely. Yeah. Binance probably will move their coins before quantum computers.
And like Mt. Gox. Mt. Gox is interesting. That's a huge wallet. And the more... I
was going to say, in this effort, though, where you're like, raising money, theoretically, the financial incentive is to get Satoshi's coins. So then how do you like square that in terms?
So I mean, if you can get, that's one incentive.
Okay, that's one incentive.
If you can get comfortable about it, right? If you can somehow.
Where you decided in your own head, this is not theft. This is like somebody's going to get it no matter what. It's a bounty. It's a bug bounty. It's actually an interesting way to think of it.
And that's I've heard
it kind of is a bug bounty.
I've heard say that.
Yeah, it is kind of is
like
a bug bounty.
Those tokens are basically the reward for getting a quantum computer and upgrading the Bitcoin to the next level.
Well, I was going to say, if I were your comms lady, if I was your like on your press staff, I would frame it like battle testing.
Yeah, and that's right. And I think that if you are a certain kind of organization, Korea, you're going to take those coins and try to spend them and break. You don't care,
Right.
But if you're
better than America gets Satoshi's coins,
and be a steward, and like you could quantum burn it, right? So you could I guess opt in to the next proposal and just burn them. Burn them quantumly, and
right. And there's many, and Jameson Lopp just put forward a proposal to burn them hopefully before the quantum. I mean, the ideal situation is that, in my opinion, many will disagree with me, is to burn them before the quantum computers arrive.
If I'm a maxi, I say, whoa, no. You're this is...
You can't change
heresy. Yeah. You're censoring.
Right.
Because you don't know.
He might come back.
You don't know. Yeah. Well, you don't know if he gave his children a thing that said, in 50 years you'll have this, and like, who are you to?
Right.
Imagine that happened, and the kid's like, what are you doing?
But if the QCs are imminent, right, and you think there will be hints along the way, right? I mean, like, we'll know if the quantum computer threat is becoming progressively more real.
I think so.
Then it might be appropriate.
Yeah, no, if Google comes out and says
we're there. I'm pretty sure the maxis will eventually burn them once we get to that point. It's just we're very far away from that, I think, is the consensus in their point of view.
I don't know. I think there are going to be people who say, you can't censor. This is against the like look at the Ethereum Classic, right?
There absolutely will, but like of course I think there will be those people, but I think that will be the minority point of view when you think about like 30 years from now, if we've succeeded and like everyone's money and the value of like all of their livelihoods depends on Bitcoin maintaining its value. Yeah. They're going to get their acts together basically and be like, burn the fucking coins. Like,
Yeah, no, I see that. I mean, I feel like, it'll be fascinating to see how the community handles it, because I think you got a little bit of hypocrisy, where
I can't imagine that in the Bitcoin community.
Where, you're saying censorship, and now you've also burned, 15%. I mean, it's not just Satoshi. It's anybody that's lost anything, right? And those are all dead forever. And so, when they changed the euro in Europe, there were countries that said, you must opt in. After this date, if you haven't turned your Deutschmarks into euros, you're shit out of luck.
Well, and I mentioned Jameson Lopp's proposal for burning. That is actually part of the proposal, is that there will be some sort of schedule for burning anything that hasn't opted into PQC friendly addresses, which will also theoretically be proposed.
I don't know how much of that, it could be 10, 20% of Bitcoin, right? And because there's entropy, right? I mean, every time.
Which would be bullish.
Super bullish.
Yeah.
But now what happens next time?
Yeah, well, this is I think the argument.
Someone's a central banker here.
Is like the precedent, right? Like I think that the you don't know if he's coming back argument is like a little naive, but the is this a precedent for changing the monetary policy is an argument.
Well, but also like what, for example, let's say Jeffrey Epstein had Bitcoin, the most hated guy in the world, toppled me. if you could censor Satoshi, why can't you censor somebody else? And eventually you get to this point where it's like, I don't like him, I don't like him, I don't like him. And,
right. The precedent problem is potentially like
the reason we made this in the first place.
Exactly. It starts to get like gray area.
Trustless, censorless.
Yeah, totally.
So, don't do it now, and it's a really uncomfortable, thing. And so I think, maybe the best way to head it off is, an intrepid, hacker sort of saves the day.
An intrepid hacker.
Yes.
Yeah. Bounty hunter is probably a better way to describe it than if that's the route that we're taking.
And if you think about the game theory a little bit more, I could see a grubby government saying, wait a second, that's our money.
Ooh.
You can't do that. And, there's a point where there's like, for example, a bunch of people who, like Craig Wright actually wrote a big thing about quantum computing. It was actually fairly erudite. I mean, for all the things people say about the guy, he's not stupid. He wrote this long white paper, and the idea that I think some people around his circle have said that abandoned property is theoretically comes into play here. And there's all kinds of,
at least in the U.S., that's an American legal precedent.
I think everywhere has some thought about abandoned property.
Oh,
like, how do you treat it? Even islands and different places. Like, what is the law on this island? If I leave this coconut here, and I don't come back for 10 years, is it everyone's coconut?
Right.
And I think that, it all depends on your social philosophy.
Do you happen to know what the actual law is?
State by state.
It's state by
state. Yeah. I think there should be a federal, because I think interstate commerce would apply.
What's the rough range? Is Satoshi's property, would it be considered abandoned already?
Yeah. Yeah. So in New York it would. And in New York, you have to make a public service announcement in a newspaper or something. You've probably seen in the newspaper, there's actually government cars. If cars get abandoned and governments say, if this is your car, it's your last chance to pick it up, and it's going to auction.
Right.
And they auction it off. And you can pull up the New York Post, you'll see it. And it'll be like, if this is your Bitcoin, this is your last chance, get your private key.
This is an argument maybe for not going after the Binance honeypot, where you'll almost certainly be you'll most certainly go to prison if they figure out who you are. Yeah, exactly. Versus Satoshi's coins. This is maybe the argument for why Satoshi's coins really truly are the low-hanging fruit, because the abandoned property.
Well, now it gets even worse, because now you're talking about more philosophical problems and maxi problems, or community problems here, where what is Coinbase going to do? If Coinbase says, we're not honoring this, you can't give your Satoshi, we're not cashing your Satoshi money out. Are you crazy? Go take that somewhere else.
I was going to say, this also goes into sort of, okay, so let's go to this sort of next layer of questions, which is, let's just say for the sake of argument, somebody succeeds, doesn't matter who it is, state, company, human being, whatever, succeeds at getting access to a cryptographically relevant quantum computer. What issues could make it such that it doesn't really help you? The investment becomes not worth it, right? So how do you liquidate these coins?
Yeah, certainly, there's lots of approaches, right? You could sort of short Bitcoin, is probably your best.
Yeah,
one of your best. So you need capital for that
short
already.
Bitcoin, then take the coins and then watch the market crater and make a bunch of money.
But the thing about that is that
is actually probably the best option.
Well, no, because so I've done this in the stock market, and what ends up happening is you have a block trade or whatever. You try to force the market down, but the market clears at the bottom and it shoots right back up.
Right.
So once the seller's out, the seller's out. So if you try to liquidate it all, and you actually do liquidate it all,
or you could just make money on the shorts. That's what I was thinking, is don't even try to liquidate it. Just take them short, make your money on the short, and then just hold the coin somewhere safe so that at least no one else can get them. And then theoretically the price of Bitcoin is protected, because you're not going to get that giant supply shock.
You might get a hit and run.
It would be your short would make money on the fear.
Briefly.
Yeah. So, I guess you don't make a ton of money, but
and by then maybe it's $1 million, or something like that. So I don't know. I don't think there's.
I think if there's evidence of true quantum theft in Bitcoin, you're going to see a pretty significant pay. You'd be able to take advantage of that, and
I think so.
Yeah.
But the question, one way to do it. This is sort of my best idea. and I shouldn't share it, but this is a very unlikely to succeed, project. But we also agree that over time, it's a certain to succeed project, so it's kind of a funny thing how it works. And I'm one of those people that says, well,
hopefully Bitcoin will get its act together and actually, fork before any of
then we worry about breaking that.
Right. But then we can just push the can down the road with all the forks. That's what software is, right?
Security is, yeah.
That's right. That's what security is. That's right. Yeah.
Yeah. Exactly. So I feel like, my best idea is if you had a magic wand and you happen to have it tomorrow, is you basically just become a Bitcoin recovery service. And you basically go to people who've lost Bitcoin wallets. They have to prove to you that it's theirs somehow. And you say, I'll get you back. Just give me half of it. And you go, the guy who has who lost his Bitcoin bought the whole, garage yard, the whole dump. That story.
Yeah, right. Yeah, of course. Yeah, the dump. The guy who lost his keys in the dump.
We'll save him.
But how do you get it back? How would the service what's
quantum? Whatever it is, the matric, whatever it is.
What if they move it to quantum secure? If they move it to a quantum,
I'm talking about if you had it today.
If I had it.
If I had it today. There's tons of stories. Everyone knows somebody.
I was going to say that's not a recovery service. That means that you're both stealing.
A recovery service. But it's your tokens you lost. If you had 1,000 Bitcoin that you lost 10 years ago because you know what the address is, but you don't have the private key, come to me. I'll get you 1,000 back, but I want 500. There's people who there's whole companies that.
Oh, I see. You're saying recovery for people who lost their keys.
Totally,
and only quantum thief. Ethically,
yeah, it's a white hat,
Right.
And I mean, you probably know and met some people in this community where.
Is there enough money in that? Do you think? Probably. There's probably a couple $1 million Bitcoin. Yeah, a couple $1 million. Excuse me, a couple million Bitcoin that's been just
something
lost
in that range.
Keys.
Yeah, it's billions of dollars, and there's this little group I met. That will do ledger recovery and other types of cold wallets. So they're very careful, but they technically they use electron microscopes. They're doing all kinds of fancy break it open. Let's read it. And their job is to recover really hard to get Bitcoin keys. And and Ledger does a really good job of stopping anybody from cracking it open. But theoretically, it's in there somewhere. And so I think that there are tons of lost Bitcoin. So that's probably the best legitimate way you can, you're doing a service to somebody. It's like a locksmith.
Tell me, okay, and remind me again, what would be your plan for how you would because you'd have to partner with one of these companies, basically, most likely, in order to
it'd be weird if you were does anybody want their Bitcoin recovered? Everyone would be what are you talking about? You're an idiot, and I think, it would be hard to advertise that, but conceptually that would be the best attitude, because other than that, you're sort of just stealing. And I think that's, not just, unethical, but it's foolish. It's very easy to get caught. I mean, we all know the stories of the guy with the popcorn tin can underneath his floorboards. That guy got caught like that.
Yeah.
Rosal Khan's the epic hack, that was pretty ezy too.
Pretty easy.
So
Bitcoin's not that hard to figure out is really the truth.
Yeah. You don't want a bunch of hot Bitcoin. It's not.
And I was going to say, if you have Bitcoin that is considered stolen, how do you turn it into dollars?
Coinbase and Kraken are not going to, mess with the, all that stuff. So,
those coins will be black market coins only. It'll be very, very difficult to actually turn them into money.
Yeah.
There'll be no rails for those Bitcoin.
Now, can they get, atomic swapped, or something like that? If the Bitcoin proposal is a...
Or you can maybe wash them, maybe tornado cash them or something.
Well, I think
even then.
So if you try to do the quantum upgrade, it can't be deterministic, I don't think, because then you can get, you might be able to reverse it. So if I'm going from old, pre-quantum to post-quantum Bitcoin, how do I make sure that that link doesn't somehow compromise me? And I think that it would be, I have to send it from here to a post-quantum wallet. And does that stay on chain? I think it would have to. And so your scarlet letter kind of comes with, but it's going to be interesting, because, with the Monero, idea is that, you never know where that, money came from, but Bitcoin is this, daisy chain of custody. And I don't know if I'm assuming post-quantum will keep that going, including the bridge,
yeah, for sure,
from one to the next, but it's it remains to be seen, how this will all be engineered. And it is a funny thing because I think, in general, all this talk, the last hour we've been talking, it's all bearish because you're pointing out the flaws, you're pointing out the issues. And so like this pops the sort of like,
Bitcoin is perfect narrative.
Bitcoin, exactly. And the Satoshi, and in
Which
fact,
we should be doing. I mean, the reason why I'm having this conversation, the reason I feel like most of the show is dedicated to the fact that we should be talking about particularly the technical issues that, are challenging for Bitcoin. Otherwise, we're just blind to
and Adam Back is doing it. And, there's plenty of great people working on this, creating technologies around Bitcoin, all that stuff. But I think one of the things you can't avoid is that, and again, people are going to crucify me for this one, but like, Satoshi wasn't perfect. Yeah. And, that's, I think.
He definitely wasn't a perfect engineer. No.
Right. And so one of the things that I think he was really not perfect on was choosing 256-bit ECC.
Really?
So, yeah. So,
that would be one of your criticisms of engineering.
Yeah. So let's do the math. So 256 bits, which is base 2, is around 10 to the 77th, which is it's a big number. 10 to the 77th, so 77 zeros. But Pollard's row is the main attack on ECC right now, and that's gives you square root of n. So it's still exponential, but you only would have to go through 10 to the 38th or 39th steps. 10 to the 39th is massive number still, but how massive is it? And that's the key thing where I think the race between traditional attempts and quantum is actually not trivial. I do think quantum will edge that out, but let's still do math. How long would it take a computer or a bunch of computers to do 10 to the 38th, 39th? Well, I wrote a program that can do around 1 billion keys a second. So that's 10 to the 9th. How many seconds in a year? It's about 10 to the 7th. So now you have 10 to the 16th, single computer. Still far away from 10 to the 30, 38th, 39th. But let's say we had, 10,000 of these computers. So now I'm adding 10 to the 5th, or maybe even 1 million, 10 to the 7th. So now I have 7 plus 7 is 14 plus 9 is 23. Now I'm about 15, 16 zeros away. Now, still a lot of zeros, right? But what if I do it over 10 years? And what if I do it with Moore's Law? So Moore's Law is a funny thing, right? You're supposed to have, and NVIDIA is actually somewhat outpacing Moore's Law, believe it or not. So,
wow.
Yeah, people think Moore's Law is dead. They're wrong. And in fact, if you look at thought leaders in AI, like Nat Friedman, he said publicly that we're going to have 1 million X compute in the next 5-10 years.
Jeez.
Because the need is there, right? We need it for AI. So we're going to figure it out. And I have a lot more to say on that too. But, ultimately with Moore's Law, if you believe that you're going to get, continued progress or even faster than continued progress, you're talking about every, 10 years, you get 2 or 3 Moore's Law cycles. So you can add zeros there. And then, really importantly, there's a little math trick here where that's the math to hack 1 key.
Yeah.
So there's a lot of Bitcoin addresses. So you have to do a little bit of division there, and that gives you another 3 or 4 zeros. So depending on how you treat Moore's Law and depending on how you treat that, there's no optionality in that.
Is there a bit number that you would have chosen, or is it just no
512.
matter what?
Yeah, 512.
512. Okay, got it.
512 or 1024. I mean, it made the chain bigger. It would be a little bit cumbersome, but we wouldn't be here.
I was going to say PQ signatures, if we add them to Bitcoin, will also make the chain bigger. I
mean,
this is going to be, if we are going to upgrade to any kind of
look how
real
close we are.
Quantum.
10 to the 9th, so 7 seconds a year, 7 for the computer, 14 to 9 is 23. Add 5 for Moore's Law, 28. Add 3 for the fact that there's so many wallets, we're at 10 to 31. We're not that far from 10 to 38, right? I mean, now 7 zeros is, you have to go 1 million times faster than that.
Right. We're still not worried about it for at least 10 years.
I mean, so one math upgrade, one math trick. It doesn't have to be a miracle.
Right. If there was an unusual advancement of some kind.
I don't think it's out of the question with AI and with, so the guy you need to talk to, and I'm going to try to do this pilgrimage, is John Pollard. So Pollard invented Pollard's Row.
Right. And, I remember you told me.
Yeah, this guy's 80 years old, and his website is adorable. It's this super old, GeoCities type website. And he's like, if you need to find me, go to this chess club in the UK. Go to Scotland or somewhere. I forget exactly where. I think it's the suburbs. He's like, that's where you'll find me.
Oh, you have to make a pilgrimage.
That's it. And Mr. Pollard, I presume, playing chess with him, so you want to take a look at some math, you know, and you have to coax him into it. It has to be like,
my God.
Really, he'll probably talk to you instead of me, but but ultimately, you know, you slide him across some math and say, how would you speed up your famous algorithm?
Oh my.
And like, you know, the guy was a genius, and he still is, you know, he's a complete genius.
It's not impossible that there could just be some unforeseen mathematical breakthrough that could like speed up this whole thing.
I would say it's a certainty.
Imminently.
You know, some mathematicians say math is discovered. You know,
100%.
It's in there in the universe. It's implicit in the universe.
100%.
It just needs to be shown a light. And Montgomery was the other, you know, crypto mathematic genius, and he passed away. But between Montgomery, Pollard, Lenstra, they were like, you know, real small handful of people that they just saw the world differently. They were able to like see numbers like totally differently from the rest of us, and they were able to find these attacks on these number systems that, you know, miraculously stuck. And like even like things like integer factoring, people don't work on this much because it's like almost, forgive the expression, but it's like almost too autistic. It's like, you know, there's not much to it. You know, it's like, why? Like, you know, other parts of math are like interesting to mathematicians at least, but even to mathematicians,
it's a little like,
it's like,
meh.
What are you doing?
It's a little boring, even for mathematicians.
Why are you trying to factor numbers faster? Like, this is dumb. You know, but there's enough of us, including, you know, mostly like godfathers like Pollard, but also, you know, someone like me, where it's like, no, I want to know. I want to know how fast can you factor.
Well, and there might be a use case in this particular.
In this case, yes, but like it's sort of laughable because it's not interesting mathematically, it's not interesting, you know, philosophically, you know. But I think, you know, depending on your cup of tea, it is interesting because you're asking this fundamental question of the universe, that why it's so easy to multiply two big numbers. So easy. Takes a nanosecond, but it's impossible to figure out what those factors were, right? And it's just like, why is the universe made this way?
Yeah.
You know, it's a cool question if you frame it that way. But if you frame it the Pollard way, he's like, I played around and he found this thing called, you know, this kangaroo method. He's like, the kangaroo hops from here to there, and there's all kinds of like funny little improvements on the kangaroo. And there's big step, baby step, giant step. There's a bunch of different philosophical like ways to think about how to do this algorithm, and I have no doubt there's a faster way to do it. No doubt. It's just a question of who can.
It is kind of like a spiritual question. Why is factoring so hard? Yeah.
And the discrete log problem in this case, you know, Bitcoin, just to make 100% clear, is the discrete log problem. It's not, you know, factoring, but they're analogous.
Right.
You know? So you raise a power and you take the modulus, and you know it sort of becomes a new question. But like I asked Grok, and so. My girl and I met, and one of the ways we fell in love was we both like biology a lot. And I said, you know, what would be a great idea is if we took every protein in the human, you know, known to man, you know, it's like 20,000 proteins. And you basically just had GPT run on each of them and say, this protein is, you know, it's a human protein. Our body's made of 20,000 proteins. What good is this for? You know, can you make a drug that would help somebody, you know, and keep thinking. Just let me know. And then you take those 20,000 and eventually, you know, you take the top 10, and those are like the new cures. The new, you know, GPT would figure out like these are the medicines that we need to improve mankind. So you can sort of do the same thing with math, where you say, or there's 20 fields of math. You know, you have, you know, just list all the abstruse, you know, fields of math, and, you know, and then say, and I've sort of started to do this, which is look at category theory, look at, you know, combinatorics, look at whatever. And Grok or GPT, I want you to think hard about combinatorics and think about what in combinatorics could help ECC. And you go through each one, and eventually, you know, Fermat's last theorem fell because Wiles thought like kind of very laterally. You know, he went around math to find like the one thing that might help. And it was elliptic curves, believe it or not, or part of it was. Right. And so he combined these like different ideas, and he attacked the problem in a new way. So I'll give you one really crazy story, which is I asked Grok to do this, and I hope somebody sends to Elon, but Grok threw me some stuff, and I was just like, no, Grok, you know, you got to think really smart, really different. Like, you know, this isn't a problem that's going to be solved like the normal way. Like, think outside the box. And it came up with one of the most esoteric fields of math called tropical geometry, which is, you know, like really out there. And it was like, he's like,
no idea.
It's like, use tropical geometry. And I'm like, use tropical geometry. Like, first of all, what is tropical geometry?
Right.
We're having dinner with some friends.
But this is how AI can lead to mathematical breakthroughs. This is a very good example.
Yeah, because if you think about like anything we do for a daily, like on a daily basis, whether it's like software or medicine, like for medicine, like, you know, everything was hunky dory for a while. We're making small molecules, chilling, and somebody said, "What if we take the antibodies in our blood and use them to make drugs?"
Right.
And it changed medicine.
Right.
Forever.
Just like how much faster can you work at literally anything if you have all research at your fingertips, basically?
But I think it's outside the box thinking because medicine changed forever when antibodies.
You can ask questions.
Yeah.
Right, yeah.
And also you can say, think creatively. You know, don't. So small molecules is like, if you stay in that box, you basically say, okay, how can I make the best small molecule? But some genius in medicine said, no, we have natural antibodies that we could exploit to make medicine. And medicine was forever changed. And then they did it with DNA. And then they did it with, you know.
And I think fundamentally we can be more creative, even if we just look at it as like we have more research at our fingertips.
Totally.
There's just like, you know, the more tools essentially. It's like having a wider color palette to like paint a painting with.
Absolutely. And you know, math is sort of finite. I mean, there's only so many subjects. So you could basically just say which of these subjects is, you know, although it's unlikely, you know, happens to be the secret key. And, you know, there's this whole idea in math called the Langlands, it's called like the Langlands, it's not a conjecture. It's like the program. It's the Langlands program. It's this whole idea that we need to link two different areas of math into like one continuum. And it's this like project in a way. And I think that like this is the sort of idea where it's like take things that are seemingly unrelated and you make these deeper, you know, amazing, some people say beautiful connections between them. And so elliptic curves, you know, are really amazing and beautiful, but like, is there a way to like burrow into them through a totally different direction, you know? And I feel like, again, I don't think tropical geometry is going to be it, but like that was really creative. Like
it will
you know,
be some outside of the box thinking that
has
does
to
it.
be,
That
yeah.
we know.
I think so. Yeah. So it's fun to try it and it's fun to explore it. And like, as you know, what's a cool project is like, so in chess, I started playing chess as a kid and I haven't gotten a whole lot better. And when I was a kid, I thought, you know, I'm going to play this game for the rest of my life. And I wonder if I get like better linearly, exponentially, stagnant, whatever. So this is sort of similar where it's like, if I work on this problem for the rest of my life, it's like chess. It's fun.
Yeah.
You know, it's interesting.
Yeah.
You know, I wonder if like one day somebody will solve it or, you know, will I get closer? Will I, you know, get further? You know, Koblitz invented elliptic curves. Koblitz has these like extremely dense textbooks. And in one of his textbooks, he comes close to solving Fermat's theorem. And he just misses it. And Wiles, you know, solves it. But he sort of like goes through how you could theoretically kind of get there. And, you know, it's really funny to me because it is just like one step away from the most famous, you know, math problem of all time. And so I feel like, you know, there's a lot of, you know, luck involved too, you know, and just kind of keeping your ears open. And AI is good at that because AI can read every paper.
Exactly.
You know, like when you hear these stories, sometimes these stories are like, you know, I had the stack of papers on my desk and it happened to be just on top.
Yeah, right.
And it was like, you know, I read.
What if you just insta-read every single one of them? Yeah, exactly.
I mean, AI won't get tired.
Exactly. Okay, so final Jeopardy before I let you go back to your very pregnant, soon-to-be mother of your child. I have to ask, did you meet her at Hereticon? Did I hear that
so close. So I met her in San Francisco and
okay.
You know, we hadn't talked for a while and I said, "Do you want to come to Hereticon?" And you know, there's a Hereticon baby. So yeah.
Oh my gosh.
Not the first, I'm told.
What was Hereticon like? Because I've never been. Hereticon is Peter's. It's right. Conference?
Yeah,
Peter Thiel's conference.
like a Founders Fund, Peter Thiel
What
extravaganza.
is that like? Just out of curiosity.
I think it's a lot of smart people. I mean, it's I think like you know. It's a place where you can be edgy without, you know, being criticized or like, you know, having fear of like recrimination. So
you can talk about hacking Bitcoin,
eugenics, whatever you want, you know, and like, you know, it's nice because like there was a friend of mine had a CRISPR booth where you could CRISPR yourself or CRISPR. She had like these tadpoles and things like that. And it's illegal to do. I mean,
CRISPR. Wait, sorry, back up.
Yeah.
What is this? CRISPR. What is this?
She had a thing where you could take home your own you could order your own genetically engineered, like, I forgot which, it was like either tadpoles or like those like certain organisms that we use in drug discovery. This wasn't Drosophila, but it was one of those.
This is something you cannot buy on the free market. No. But
and apparently it's like.
But if you go to Peter Thiel's conference, you can get a genetically engineered animal.
yeah. So I think you get a lot of interesting, smart people, and then put them in a place where they don't have to be scared.
How big was it, out of curiosity?
Like 1,000 people, maybe 500.
1,000 people, 500. Yeah,
something like that range. Yeah, really great people. Yeah,
I know. I've heard throw a stone, and like you're like talking to the most interesting person you've ever met.
Yeah, and I think that for me, I just went to talk about prison and like who's a heretic? Right? Right? And yes. I think like somebody who. There's all kinds. But, I think...
You went with the intention of talking about prison? Like, what was your...
Yeah, I gave a little talk about, like, a mix of things, but mostly just, like...
What was the...
It was just kind of like a generic my story, but, like, I got into this huge trouble once for making this joke about Hillary Clinton, and it actually accelerated my imprisonment and lengthened it. And
really?
Yeah. And there was this famous other guy who did a much worse thing.
Was that like explicit? How do you know that?
Oh, yeah.
They were like, you dissed the former first lady, your bad behavior, you're staying in.
Yeah. It was bad. And
wow. When was that?
This was right around the time of my whole, crazy period in 2015, 16, 17.
Was this like on Twitter or something?
Yeah.
You criticized Hillary Clinton on Twitter.
So it was a crazy joke. It was like this dumb, this theme of like the lizard people. Some say like,
Right, yeah.
So I said that I needed Hillary Clinton's DNA to see if she was a lizard person. And they were like, this is a crime. You cannot like, incentivize the, I'm just like, come on, guys.
Oh,
it's a lizard.
My gosh.
Like,
how much did they extend you?
Well, my lawyers, it's not exact, but my lawyers say like, you looked much worse in her eyes when she had to throw you in jail.
Right. You were supposed to be on best behavior.
Yeah, she was not amused. And, judges are the kind of people that are like, this isn't funny,
Wow.
So, that hurt.
Wild.
And, there was a guy that made the you can text your vote. Joke. Yeah. It was a joke.
Was it? This was a joke.
Yeah, he got indicted. Yeah.
Whoa.
He got indicted and convicted. Yeah.
Whoa.
And it was like, don't wait in line. If you want to vote for Hillary, just text this number. And, it's sort of hilarious because people should know, like, you can't text your vote.
Right.
But some people did stay home.
He was convicted for that.
He didn't get to do jail time, but, ultimately.
But he got a big slap on the wrist for that.
Well, he eventually got it thrown out.
Okay.
But it was like.
A whole thing.
It's election fraud.
Yeah,
so there's so many things that we think no big deal, but it's like, no, it's federal crime.
Be careful with your jokes. Yeah.
And math can be illegal too, right? I mean, AI is math. It's linear algebra.
Right.
And there are many people, like Kamala wanted to make AI, like there'd have to be, in fact, there's specific laws that say if your computer's this powerful, you have to register it with the government and you cannot do math with that computer unless we say you can. And this was PGP as well, right?
Those laws exist?
They tried. And
but it didn't work.
JD and
but Kamala presented
that, and also the state of California, and eventually
that's so authoritarian. It's so insane. It's wild.
And it's literally multiplying numbers,
wild. Right? It's amazing to me that more people don't know that was
PGP was the same.
Forward.
PGP was PGP, and a lot of people think Satoshi was a guy who worked on PGP and stuff like that. But like PGP was classified as a military weapon, right? And you could not export PGP because you were exporting a military weapon. They found a way to like make it illegal. So like I think Shores could go that way.
Shores could
Why not?
go that way.
It's classified math. It's illegal math.
But I thought that was like overturned, right? Like so back in the day, right?
Was,
it didn't end up sticking. It was like no, code is speech.
I have the freedom for division.
Right. Freedom of math. Math is speech. That's what we're gonna just go with. That might be a theme of our chat.
I hope so. But,
freedom of math.
I also don't want somebody to do some math and hack my credit card, right? So it's reasonable that want protection.
This is really the question, I think, with the quantum computers. But I feel like we did a good job hashing it out. Thank you so much for coming on. And it's fascinating to kind of get your take on this. There's very few people, I think, who are thinking about this as deeply as you.
Thank you so much. Maybe we'll be back in 5 years and we'll see.
We'll do an update in 5 years. You'll have a 5-year-old at that point.
That's true.
Oh my God. Do you know it's boy or girl?
It's a boy.
Oh, congratulations.
Thank you.
Well, thank you so much for taking the time.
Thank you. This is great.